this tutorial, we will start on designing the chiller system that will feed our air handling unit. As we learned before in part 1, the chillers can be classified according to the type of the substance that is used to condition the air. And for that, we have the water-cooled chiller and the air-cooled chillers. So for the water-cooled chillers, the water is used to cool the water that is going forward inside the air handling unit. And for the air-cooled chillers, the air is the source that is used to condition the water that is going directly inside the air handling unit. So the chiller supplies the air handling unit with the cold water, and then the air handling unit supplies the VAV boxes with the required conditioned air through the ducts. So that was a quick revision to refresh your mind. And now let's start inserting the chiller. And for that, we will use an air-cooled chiller, not a water-cooled one. And because we have added the air handling unit on the roof of the school, so we will add also the chiller on the roof of the school. And for that, we go to the System tab, and then Mechanical Equipment. And after that, we will load the family as we need the chiller now. Then we go to the libraries. After that, US metric. Then we choose the mechanical file. So we press on M, that's the mechanical file. And now MEP. After that, the water side component, not the air side component now, as we are going to export the chiller. And this is because the output of the chiller is the water that is going forward through some pipes to the air handling unit. So for that, it's a water side component. And those are some different types of the chillers that we can use. So let's go down. Here we have the rotary type chiller, the screw chiller, and the scroll chiller. So let's choose that chiller here, which is of the type M screw chiller, air cooled. And then we press on open. Very good. This is the chiller as you see. And now let's place it at that position, for example. And then we press on escape. And another escape. Now let's explore it closely. So if we zoom in and if we select that chiller, so as you see, we have an electrical input here, which is used for the electrical supplying power. And also it has an input terminal here for the input water that is going input for it, or for the warm water that is going out of the air handling unit inside the chiller. So this is the input terminal for the backward water that is going back from the air handling unit. And here we have its output. And its output is the cold water or the conditioned water that is going out of it through another pipe, and it will go directly inside the air handling unit. So its input and its output are connected to the air handling unit, and this is because the water is going through a closed cycle from the air handling unit to the chiller, and from the chiller to the air handling unit. Very good. Now if we do the same thing with the air handling unit to check it, and if I select it, you will find that it has an output terminal here that is used for the warm water or the hot water out of it back to the air handling unit. And also it has another input, but to see its input, we can make a section. So if I select that section and if I press a double click on it, now let's zoom in and select the air handling unit. So you can see this is its output terminal that is connected to the pipe that is going to the chiller, and this is its input terminal that is connected to the input pipe, and it takes the cold water from the air handling unit. And for that, you can see this is a red sign which refers to the warm water, and this is a plus sign which refers to the cold water. Very good. Now we can close that section. And now we need to make the connection of the pipes between the air handling unit and the chiller. But you know, we cannot connect the pipes directly from the chiller to the air handling unit. And this is because we need a pump that will push the water from the chiller. And for that, we need to add a pump between the chiller and the air handling unit. And to select that pump, we go again to the mechanical equipment, and then we press on load family. After that, we go to the libraries, then US metric, then the same mechanical file. After that, MEP, and then we go again to the water side component, as the pump is a device that is used to push the water, so it's a water component. And then we select the pumps. Here you can see we have many types of the pumps that we can use, but for us, we will use the pump which is the base-mounted one, and then we press on open. Very good. Now we can paste it at that position. For example, here it's at the middle between the chiller and the air handling unit, and then we press a double escape, And also let's explore it for its input and its output. So if I select it, you will see it has an input which is connected to the input pipe for the input water that is going inside it to push it. And it has another terminal for the output which is connected to the pipe that push the water out of the pump. All right. But for now, we will not connect the pipe directly from the chiller to the air handling unit. So what we want to say is that the input pipe for the pump is connected to the output of the chiller or the output pipe of the chiller. And the output pipe of the pump itself is connected to the input pipe of the air handling unit. And for that, we need to make that required routing operation. And for that, we will access the chiller that we have, and we will access its output pipe. But for that, we need to make a section, or we need to make another section. So we go to the section tab, and we start from that point to that point. And then we access that section, and let's zoom in. Now we access the chiller, and then we access its output pipe. So we press here a right click, and then draw pipe. And now let's go there a little bit, or let's go up a little bit. And then we go forward here until we go to the output of the pump that we have until that point, for example. And then we press on escape, but let's increase the details level to be fine. And then save the project. Very good. This is the pump that we had just created. Now we connect it to the input of the pump. Here we select the pump, and then we press a right click on its input, and then draw pipe. And that pipe will go until that point, and then we connect it up to be connected to the output pump of the chiller. Very good. Here we have connected the output pipe of the chiller to the input pipe of the pump. Now we will do the inverse of that operation, which is to connect the output of the pump that we have with the input of the air handling unit. So we select the terminal of the pump here and press a right click, and then draw pipe, and let's go up a little bit. Here we go up. After that, we press on escape. And now let's end that section. And then you can see this is the pump that we had just created. We select it and then draw an horizontal pipe until that point. This is a good one. And then we go forward here until that point. Now we press on escape. So to make this section, we go to the section command here. And let's start making that section from that point to that point. And then we swap it to change its direction. And also let's increase its view range. Here it's forward view range, we increase it. And then we access that section. Very good. Now we can increase that section also from the upper level here until that point. As you see, this is the pipe that we had just created, but let's at first change the details level so we make it to be fine. Very good. This is the output of the pump, and this is the output pipe for that, and it will be connected to the input of the air handling unit or its input pipe. So that's the input pipe of the air handling unit. We press a right click and then draw pipe. And then we go forward to connect it with that pipe here. Very good. Here we have connected the input of the pump to the output of the chiller. And we have connected also the output of the pump to the input of the air handling unit. Now what we need to do is only to connect the output of the air handling unit to the input of the chiller directly. And for that, we can select the air handling unit and then press a right click and draw pipe, and let's make it to go forward here until that point. Very good. Now let's press on escape, and then we close that section. And after that, we change the details level. So we make the details level to be fine. And then we select the chiller, and we can access that section. So from that section, we need to go out of the chiller with the input pipe. But at first, let's increase the upper limit of that section. So we drag it up here. Now we select the chiller again and press right click, and then draw pipe and go here and then go up until that point and connect that pipe to the air handling unit output pipe. Very good. Here, what we did exactly is to connect the output of the chiller directly to the input of the air handling unit, and we connected the input of the chiller or the input pipe. As you see here, we connected it with the output of the air handling unit, but we connected it through that element which is that pump, as that pump will push the water from the chiller to the air handling unit. So to see the full picture, we can increase that section here. As you see, this is the full picture we have, as it represents a complete cycle between the chiller and the air handling unit through the pipes out of them input to the other part. And we can imagine that well in the 3D form. So if I select that part here, and then I press on the selection box, you can see this is our system in the 3D form, but let's increase the details level as usual to be fine. Here you can see this is the pipe that is going forward from the chiller to the air handling unit, and this is the other pipe that is going from the air handling unit to the chiller, but it goes through the pump here, as the pump works as an intermediate between the chiller output pipe and the air handling unit input pipe. In this tutorial, we will continue designing the piping system required for the chiller, the pump, and the air handling unit. As we see in the previous tutorial, we ended with the routing operation between the chiller, the pump, and the air handling unit. So we have connected this closed loop system with the required pipes. And now we need to perform the sizing operation of those pipes. So to make the sizing operation, we can select easily one pipe, and then we press on tab, and here the whole of the pipe has been selected. You can see it's highlighted in blue. Now we press a left click, so the left click to ensure that we have selected the pipe, and then we go to the duct pipe sizing. And here we have two sizing methods, the velocity method and the fraction method. So we will set it to P, the velocity method. And for that, we need to set the velocity of the water that is going inside the pipe. But if you remember from part 1 of our HVAC course, we said that the water velocity ranges from 2 feet per second till 10 feet per second. Of the ideal or the recommended value is to be 5 feet per second. So we need to select it here to be 5 feet per second, but you can see the units here in meter per second for the velocity. So to solve that problem or to change the units that you have, we can press on cancel, and then we go to the manage tab. After that, we select the project units tab, and then we set the project. And here we need to select the module that we need to change its units. So we need to change the units of the piping system, as we are working now on the piping system. And if we go down, we will find that we have the speed as in meter per second. So this is the default value. We can change it. And here, instead of meter per second, we will set it to be feet per second, and then a K, and then a K. And after that, we can select our pipe again and press on tab and press a left click to select it. And then we press on duct pipe sizing, and now you can see the default value of the velocity is 4 feet per second, but we can change it to be 5 feet per second, and then we press on OK. Very good. You can see the pipe diameter has been decreased. So if we select it and we go to its properties, here its diameter has been changed automatically to be 50 millimeter or 5 centimeter. Very good. Now we will do the same thing with that second pipe. Here I select it, and then I press on tab and press a left click, and then go to the pipe sizing and make it also to be 5 feet per second and press OK. Very good. We have decreased the size of the pipe also. And then for the rest of the pipe we select it and press on tab, and then a left click and the same thing, pipe sizing, and we set it with the same value and press OK. Very good. Here we have sized the whole sizing of the pipes that we have as we need, with the required velocity to be 5 feet per second. Now at that point, after making all the required modification operations, we need to add some controlling elements on the pipes to control the water flow through those pipes. So the first element we need to add is a controlling valve that controls the flow of the water through the pipes. So we need to add a valve that works as an on or off controlling valve, as in fact, and sometimes we need to allow the water to flow through the pipes, and in some other times we need to prevent the water from the moving operation through the pipes. And for that we go to the system tab, and at that time we go to the pipe accessories, as the valve lays inside the pipe accessories tab, and then it asks us if we need to add a pipe accessory family. So we press on yes, and then we go to the Lacris US matrix, and here we search for the pipes. So that's the pipe, we press on it. After that we select the valves. Now we need a controlling valve. As we said, we need an off or on controlling valve. So we search for the controlling valves. That's it. This is the control valves. We access that folder, and here you can see we have some other types of the controlling valves. So this is the three-way valve that we have talked about on the part 1 of our course. We have a motor control valve and another one with some other dimensions and so on. But for us now, we will select that motor control valve and we press an open, and then to add it, let's go to the front view. So that's our view. We can zoom in and then we can go there a little bit. And we need now to put it at the return pipe of the air handling unit. So we can put it at that position. Very good. We have installed our controlling valve successfully. So if I select it, you can see it's a motor control valve, which means that it's a motorized valve, which controls its output to be on or off with a motor. But an important required modification now is to change the diameter of that ingoing valve to P as the diameter of that pipe. So if I select that pipe, I see that its diameter is 50 millimeter. And for that, we can access our valve. And then we go down to change its diameter. So its diameter now is 15 millimeter. This is a very narrow one. We change it to P 50 millimeter. Very good. Here it fits our need and it will control the flow of the water out of the air handling unit. And then the second controlling element we need to add is the balancing valve, which is used to set the pressure or the water inside the pipe to be at the required value to allow a stable movement of the water through the pipe. So let's add it by the same way from the pipe accessories. So we go to the system and then mechanical equipment and then pipe accessories and load family, and the same thing, we go to the same path and then valve and then balancing valves, as we need a balancing valve, and those are some different balancing valves. So what we need now is a straight balancing valve. Here its diameter ranges from 15 to 50 millimeter. Then we press an open, and after that we need to put it inside our return pipe also. So we put it here at that position. Very good. That's about our balancing valve. Also, we can check its diameter. So if I select it and then go to its diameter, you can see it's set by default to P 50 millimeter. Very good. So as we said, the balancing valve is used to set the pressure and the water inside the pipe on the required value to allow a stable movement of the water inside the pipe. Now the next part we need to add is a gate valve, and the gate valve is a manual controlling valve that is used to control the flow rate of the water inside the pipe. So we can prevent the flow of the water totally using that gate valve, or we can control the flow of the water inside the valve partially to close it partially or to open it partially. And to add that gate valve, we do the same thing. We go to the pipe accessories and then load family and then libraries and US metric, and then pipes, after that valves, and then we search now for the gate valves. So we press on G, that's it, those are the gate valves. And here the only gate valve we have is that gate valve. We select it and press and open, but now we will not add it on the return pipe as we need to add it at the forward pipe here. So we add it at that position, for example, and that's it. So you can see that gate valve is connected to the output pipe of the pump, and the input pipe of the pump is connected to the output of the chiller. And for that reason, we are connecting now that gate valve to the supplying duct, not the return duct. Now we can change also its diameter. So if I select it, here I find that its diameter is selected manually to be 50 millimeter. More than great. And finally, we need to add another element which is called the strainer. And the strainer is nothing but a filter that is used to filter the ingoing water from the chiller to the air handling unit, as it filters it from the impurities that is carried by the water. So we need the water that enters the air handling unit to be free of the impurities, and for that we use that strainer as the filter. And to access that strainer, we go to the same way, the pipe accessories and load family, and then pipe, and now we would go to the accessories, and let's go down here. That's the strainer we need, which is the Y strainer, and it's called the Y strainer because its mechanical structure looks like the Y letter. Now we press on open to open it, and then we can paste it at that position here, and then we can paste it at that position here. So that's about the Y strainer, but it doesn't appear totally with its Y shape because it's installed horizontally here and we need it to be installed vertically. So to see the full structure of the strainer we can select it and we press on that loop here. You can see this is the upper part of the strainer, and at that part the water impurities are collected while the water itself is going from the chiller to the air handling unit with no problem or with no impurities. And finally, we need to change its size. So if I select it and then we access it down, so we need its diameter to be about 50 millimeter, and the 50 millimeter is about 2 inches. So we select that 2 inches, and that's it. As you see, our strainer here has approximately the same diameter of the pipe that we have. So that's about this tutorial, at which we have finished the operation of connecting the chiller system and making all the routing operation, and we connected the controlling elements that are used in our piping system.